Thank you for having me once again on the Circuit Forge Network. Today, we are diving into something that we all use every day, every hour, and sometimes every minute. Yet very few people stop to ask the question, how does the internet actually work? We scroll, we stream, we shop, we bank, we watch videos like this one, all on the internet. But how does this invisible network actually connect billions of people and trillions of devices around the globe?
Let me ask you something. Have you ever thought about what happens when you tap your phone and a website instantly appears? Where does that information actually come from? Is it floating around in the air? Is it stored somewhere in the clouds? Well, first things first, the cloud is not some magical space in the sky. It is just someone else's computer, a server, sitting in a massive data center somewhere in the world. So, when you send an email or stream a video, you are really connecting to computers in different locations. But how do we make that connection happen so fast? Think of the internet as a giant postal system. But instead of letters and packages, it is moving tiny packets of data zeros and ones, millions of times per second. When you send a message or request a video, your device breaks it into small chunks called packets. Each packet is labeled with the destination address, kind of like writing where the letter should go, and then sent on a journey through a series of devices called routers. These routers are like the postal hubs of the internet, reading the addresses and forwarding the packets closer to their destination. But what are these addresses? You might have heard of IP addresses, those strings of numbers like 19.216.811 ou 8.888. Every device on the internet is a unique IP address, kind of like a phone number. That way, data knows where to go and where it came from. Without IP addresses, packets would just float around aimlessly with no way to reach their destination. Here is something cool. When you type a web address like www.example.com, you are not actually using the real address yet. You are using something called a domain name because it is easier to remember than numbers. But the internet needs numbers, not names. That is where something called DNS, the domain name system, comes in. Think of Sistema de Nomes de Domínios like the phone book of the internet. It takes the name you type and translates it into the IP address of the server you want to reach. Only then can your packets start their journey. Now, how do these packets travel? You might think it is all wireless, like we few mobile networks, but most of the internet actually runs on physical cables, millions of miles of fiber optic cables running under streets, across countries, and even under oceans. Yes, under oceans. There are huge submarine cables connecting continents, allowing you to send a message from New York to London in just a fraction of a second. These cables carry light signals that move at nearly the speed of light, which is why the internet feels so fast. What about when you are on Wi-Fi or using your mobile phone? That is just the last step, called the last mile, which connects you to your local network provider. Your request still travels through those giant fiber networks, bouncing from router to router until it reaches the right server, collects the information you asked for, and sends it all back in packets that your device reassembles into the website, video, or message you wanted. And here is an amazing thing. All of this happens in milliseconds. You click on a link, and your device quietly does thousands of tasks, checking Sistema de Nomes de Domínios, sending packets, routing them, receiving data, reassembling it, and you barely notice. That is how seamless the internet has become. But who controls all this? You might think there is one big internet company, but there isn't. The internet is actually a network of networks. Thousands of different networks owned by internet service providers, telecom companies, universities, businesses all interconnect and agree to share data using standardized rules called protocols. The main one is called TCP, IP, which stands for Transmission Control Protocol, Internet Protocol. This is like the universal language of the internet, making sure that devices, no matter where they are or who makes them, can talk to each other. So, when we see the internet, we were really talking about this huge interconnected web of independent networks. There is no single switch you can turn off to shut down the entire internet, although parts of it can be blocked or disrupted. That is why when a cable is accidentally cut, or a bit server goes down, only parts of the internet slow down, not the whole thing. Now, let us talk about speed. Why is some internet fast and some slow? That depends on a lot of factors. The physical distance to the server, the bandwidth of the cables and devices along the way, and even how many people are using the network at the same time. Imagine trying to send cars through a highway. If it is wide and clear, traffic moves fast. If it is narrow and full of cars, then slow down. That is exactly what happens with internet traffic. What about security? If data is flying everywhere, can someone intercept it? Yes, and that is why encryption is so important. When you see that little padlock icon in your browser, it means the data between your device and the server is encrypted, making it much harder for anyone to read it if they intercept it. This is critical for things like online banking, shopping, and private messaging. Here is something many people don't realize. The internet you use every day, websites, social media, streaming is just a small part of what exists. There is also what is called the deep web and the dark web. The deep web includes things like databases, academic research, and private network stuff not indexed by search engines but still perfectly legitimate. The dark web, on the other hand, is a small section of the internet that requires special browsers and is often associated with illegal activities. But don't worry, your everyday browsing doesn't take you anywhere near there. You might also be wondering about the cloud. People talk about storing photos or running apps in the cloud. But like I said earlier, the cloud is just a fancy term for powerful computers called servers sitting in huge data centers around the world. Companies like Amazon, Google, and Microsoft run massive cloud networks that store data and run applications for millions of businesses and individuals. So, when you back up your phone to the cloud, it is really going to these giant server farms connected to the internet. Now, let us consider what happens if the internet stops. Have you ever had a power outage or your internet went down at home? Feels like you can't do anything, right? That is because so much of modern life depends on it. Communication, commerce, entertainment, even critical infrastructure like hospitals and transportation. That is why governments and companies invest heavily in making it resilient, building backup connections, redundant servers, and disaster recovery systems. And here is where it gets even more exciting: the future of the internet. We were seeing technologies like 5G, satellite internet constellations like Starlink, and quantum networking coming into play. These promise even faster, more reliable connections anywhere on Earth, even in places that don't have traditional infrastructure. Imagine being in a remote desert or deep in the ocean and still having internet access. That is where we were headed. So, to sum it up, how does the internet actually work? It works because millions of devices all agree to talk using the same language, because we have physical cables and wireless links that connect us globally, and because every packet of data knows exactly where to go and how to get there. It is one of the greatest engineering achievements of our team, and yet, we use it so effortlessly we hardly ever think about it. Thank you for joining me once again on the Circuit Forge Network as we explored how the internet actually works. If you enjoyed this breakdown and learned something new, please like this video, subscribe to our channel, and share it with someone curious about how the world around them works. And don't forget to drop your questions in the comments. Your question might be the topic of our next deep dive. Until next time, keep learning, keep exploring, and keep building with us here at the Circuit Forge Network.